Hi everyone, welcome to the second video. In this video I'm going to quickly go through what git commits are. Now git commits are the, if you will, the checkpointing or the call that you use to checkpoint your file system. Because as I mentioned in the last video, a file system or a git folder creates this mini file system on your in your directory, and there'll be points when you've created changes or you've added code where you want to say yes, snapshot this what has been changed in the directory since the last commit is what I want to sort of bookmark, right? So what a commit does is it holds a snapshot of the git directory state. So what this does is that it actually differentiating from other version control softwares like VCS, where essentially they take an empty file and they add deltas to it to generate you the final file here by adding all of these deltas together. Git actually creates entire snapshots of your system. So each one of these sort of columns here is a commit, which is a complete snapshot of the directories. Now you'll see here that there are these sort of dotted files. Now Git works in a very similar way to like how C works, in that you also have pointers, so that you can just say, for instance here, in this commit, between this commit here and this commit here, C2, the file, let's say, hasn't changed. So we don't actually need to include it in the new snapshot. We can just point to it to say, hey, this file is C2, nothing's changed. And so this is the way that Git can sort of store the entire file system while keeping the overhead quite small. So if you change one file, it will snapshot essentially just the one file and then point to the rest of them. So a git commit is a snapshot which is stored in a compressed blob, and these can be found in the .git folder, I think under objects or something like this, right? So, and each git commit, then how you will reference them, you have to attach messages to them, which I'll get to in a minute, about which sort of explain what happened or what was implemented in the commit, why the commit is relevant. But essentially each commit itself is hashed and creates a SHA-1 hash. And so these hashes are the keys that you use to reference commits, meaning they're all unique. And by doing this is sort of what you'll get. Once you get into more advanced Git usage, you'll need to be able to reference individual commits. So here we go. I mentioned they all have to have a message. And essentially, a git commit is a very simple thing. And I think the easiest way to explain them will just be to go and do an example. So the one thing that a git commit requires is a message. This is given by the -m. I think, did I have it here? Yes. So you use this as the command that you'll need. And you'll use the -m option and then some string inside of quotes. So there's some quite important things, well, not quite important, but good practice of Git commit messages. And this is that they should not explain how you did something, but they should explain, what and why you did something, right? So you want to give a context to why your work was relevant, and then you want to say like what you did. So I added this module. Why? Because the module was needed. I don't know what. So you wouldn't say how something was changed. You wouldn't say expanded on modules file to add module. I mean, people can go into the diff and see this, but you want to sort of give a verbal summary of what happened, right? So here in this example, we have what? So blah, blah, blah. The button polling module was added, and why it was added to consolidate button handling into a standalone interface, right? So if someone gave a commit message of saying the button module file was written, blah, 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 then this is a how, and it doesn't really help me because I can just go into the commit and see what was done. I can see how it was done from the git commits differences itself, right? So these, if you want to go into the real details of like long commit messages, it's essentially just good formatting. But if we go to this example here, essentially most commits will only really need this line here, because they usually be quite short. If you're doing sort of large patches for large open source projects, especially for projects where the developer or the maintainer might not be particularly aware of what you're doing, you sort of drop a new feature on some open source project and they want to know some of information and background, then you sort of expand it to have this large description. But usually a short 1 or 2 sentence description of a commit for most cases is fine. But there's sort of another important thing to do, and we'll get into this in some other videos when we talk about like issues and pull requests, is that you can link to certain things. So these numbers they're either issues or pull requests on, this is generally like a web platform specific sort of like GitHub, where someone can open an issue, like for instance, number 123, your patch solves this issue, and then you can reference it so that when people go into the issue, they'll see links to your commit. It's essentially just a bookkeeping thing, right? So enough about explaining what a commit is. We'll go and we'll create one. So now I have my repository, which I created and I cloned. So now I'm in my repository. And so now we'll look at making a commit. So if I use git status, so git status shows you the status of your repository. You'll see here that I'm on branch master. We'll get to branches in a minute in another video. But there is nothing to commit. I'm in a clean tree. So this means that my files, like nothing has changed since the last commit. So if we look at git log, which shows you a log of all of your commits, we can see here we have that one initial commit, which we can also see in our web interface if we click on our commits here, and it shows us this. And so this will just be the automatically generated commit from GitHub, where it added the files. This license, there's a git ignore, and there'll be the readme there as well. So let's create something. So let's put a line, this is the first line, into a file. So we'll make this our file.txt, right? So we now have a file called our file. Inside this file is the line that we just added to it, right? But if we look at git status, it's still saying nothing added to commit, like we still have nothing to commit, but there is a file in our repository. So this is an untracked file. Now, my experience with untracked files, my knowledge of untracked files is probably not as in-depth as it should be, but these are something that don't really affect people, and so that much, and I'll sort of give my general knowledge of them. An untracked file is essentially a file, it's either a file that is being ignored by the git ignore, so meaning that the git shouldn't really track its changes, or it's a new file. Like for all practical purposes, these are sort of the two cases that you'll come across commonly for untracked files. They're either newly created and haven't been added to the repository, like using git add, which I'll mention in a minute, or they're just being ignored via the git ignore filters. But essentially, to create a commit, you need to add things to it. And so if I go to here, you'll see here that there's this thing called the staging area. Now the Git works in a way that you have your working directory. And so this is essentially just the file system, right? And this is where you create, delete files. But the way that you actually make a commit is that you have a staging area, which is like a virtual sort of space where you add files to this like commit, or you take them out. And so you sort of are choosing what you want Git to put into your next commit, right? And so if the files haven't been added to the staging area, when you try and commit, nothing will happen. And so we can see this. If now I have essentially nothing added to commit, if I try and make a commit, like nothing happens. Essentially, we just get the output of git status because it's trying to say, hey, nothing's happened. Because if you want to create a commit, you need to add them to the staging area. These files need to be tracked. And so we have this one, we created this file, but it's currently being untracked. So to add it to a commit, we need to first track it, right? And this is done using git add. So this here is the core command for adding to the staging area. And then once, and I'll go into these two here in a minute. And yeah, so firstly we'll just add it, and then I'll go back to what exactly is happening. So now we have this, so if we go git add our file, we can now, if we go git status again, we'll see that we have changes to be committed. So we have added something to our staging area. We have changes that will end up in the commit, and the change is we've created a new file and it's our file, right? So now, like I said before, Git doesn't create deltas explicitly, right? It creates snapshots. So, but deltas, or in the computer science sort of world called patches, these are very important to have or be able to generate. So the difference between two commits is seen as a diff or a patch, right? And this can be found by using git diff. So if we go git diff, oh wait, I'll need to, hold on. Let me just firstly commit and then I'll do a diff. So the diff at the moment, oh wait, sorry, no, git diff because it's in my cache. There we go. So we'll now see that the difference since my last commit is this, it's the changes to the out file. There was a new file created, and then this is the line. At line 0, we've added one line, and this was the addition, right? So this is git diff. I'll do another example in a minute using git diff, but this essentially allows you to generate patches. So if I was also to do this to our file.patch, you will get actually a patch, and this can be used like a classical patch, right? So just to clean this, keep this clean, we'll remove that. But now, essentially, I can run the same command again, and we'll get a different output because now I have added something to my staging area, and so I can actually create a commit. And so in the diff here, we had the similar output that we have a new file. You'll see this again. We have created a new file, one file change, one insertion. So one line was changed and it was in our file.txt. So now if we look in git log, we'll see that we have a new commit. So now if I was to add a second line, so not git echo, a second line, oh, it looks like I've done this before, to our file.txt, right? So now if I cat our file.txt, we'll see a second line in there. And now before creating commit, I can run git diff again, and I'll see a very similar output, but it's showing you the patch, essentially saying that we added a second line, right? So the thing about commits is, and that staging area, is that if I created a second file, so I want to create a second file, right? So now if I run git status, I can see that I modified our file.txt and I created a second file. You might not want to include all of your changes in a commit. Like let's say that you fixed 2 bugs in 2 separate files, but you sort of did them at the same time. Now you want to, generally the good thing, or the good practice with commits is to keep a commit sort of concise and applicable to one issue or one problem, one feature or something. You don't want to make, generally if you make a patch that fixes 20 issues, someone who's reviewing your code won't be able to see which change fixed what issue. So you need to be able to be selective about adding files to your commits. So we now want to create, let's say, a commit where we only show the changes to a second file, which is the new file that we are untracked. You can see here that there's been changes, but they are not staged for commit. So if we do not want to add them to the commit, we simply just don't add them using git add. But we want to add a second file, so we'll add a second file. And now if we run git status, we'll see that a second file is being staged for commit, but whereas the other one isn't. So now if we commit it, changes to the second file, and if we git status, git log, we'll now see we have another new commit. And if we push this, which I'll go into in a minute, what this exactly is, we can then see in the web interface, we go into our commits, we'll see our most recent one. If we click on it, we'll see that there's only changes to a second file because we didn't stage the first file's changes, and therefore we were very selective in what we added to our commit, right? I think this will be a small example. But essentially, I mentioned before in the first video that you have these remotes, and so in our case, if we look into the git config file, you'll see here this remote origin. Now, origin is the default name given to the remote, and so in our case, it is this GitHub. My username, it's this, and then this is the repository. It's this guy here on the left that you can see. And so when you create a change, you're creating, like when you're creating a commit, you create this commit on your local machine, and you need to then update the remote with these changes. This is not done automatically, and this is by design, that you can be very selective in what you send to your remote repository. So a good way of seeing this, if we look at git log, we'll create a new commit, because you'll see here that this is the remote origin and this is the master branch, which is a branch we're on at the moment. I'll get into branches in another video. You can see that they're at the same point because I have these 3 changes on my local machine, whereas on the remote, I also have the 3 changes. But we'll add, if we look at my git status, I can see I have these this file here. So I will add it, git commit, more changes to our file. All right. And now if I look at git log, I will see that my head, my master branch, and head is the pointer to the most current, the sort of the most recent commit. I will see that here, using this commit, locally I am ahead of the remote. So if I update my remote to see, I still have 3 commits. It doesn't have any knowledge of this commit because it is still here. And so once I push, by using git push, specifying the remote origin, and the branch, being in this case master, because if we look at git status, it will show you that you're on branch master. So git push origin, the remote, and master, the branch. It will then send this commit to the remote. It will update any commits. It will send any commits I've made since my last push to the remote. So now that you'll see it pushed, blah blah blah, and then if we go into the git, the web interface, we'll now have this commit there. And so this is the means of sending commits. So this is some example, and now we'll get onto branches. And so branches are very powerful and very important. So that'll be in the next video. And let's just stop recording.